Welcome back to Panda Wars. We looked at the neodymium magnet test on these pandas, and we're going to be having a bit of a look at the science behind this. And we'll start off by just repeating what we've done before, holding the coin at approximately 45 degrees. Come on, focus. And on a genuine panda it should slide down the coin slowly, and as you can see on this particular one it's rather fast. Now the reason for this is
silver affects the magnetic field of the magnet, creating a charged current effect, effectively making a magnetic break that slows it down. Whereas you might think that because it's not magnetic, silver isn't magnetic, it would not affect the magnet in any way. But in fact we've got a little bit of an experiment to show that non-magnetic metals actually disrupt the magnetic field.
Anyway, we're going to show you this other experiment which will sort of help explain the neodymium magnet and its effect on all metals, really, any conductive material.
Yeah, pretty much.
And I do believe that silver is actually the highest conductive, is that correct?
It is, yeah, it's more conductive than gold.
More conductive than gold. So there you go. Right, on to the experiment then. Here we have a length of 15mm copper pipe, and this experiment will show you how non-magnetic metals affect a magnetic field. If my assistant inserts the magnet in the top of the copper pipe, we'll see how long it takes to fall to the floor.
Quite a while.
Quite a while.
So now we'll have a little clip to show you what's going on exactly inside the pipe.
And now we'll do the same test, but instead of dropping the magnet through the pipe, we'll drop it next to the pipe and see how long it takes to fall to the ground. Here we have our little electrolysis setup with a piece of copper and as an electrode, and obviously we will be attaching that fake panda in the hope of decomposing it by means of electrolysis.
But remember, kids, when dealing with potentially dangerous chemicals, and in our case electricity, always wear the appropriate safety measures.
And on this occasion we will be wearing full face safety protection and additional hand protection. Now that we've satisfied the health and safety buffs, here's our little electrolysis setup with the fake panda on the left and our copper electrode on the right, and if my assistant would like to power it up, we'll see what happens. See if it goes bang. Oh, there's a reaction I see happening there straight away on the panda
and on the copper electrode. We are in fact using sodium chloride aqueous electrolyte to ensure breakdown of the silver. This is all done from chemistry revision, no idea if it's going to work. So presumably the silver should start to break down soon, as it is on...
Or silver plating, should we say?
Silver plating, yeah.
So zoom in on that panda.
Effectively, as the atoms of the electrodes ionize, they will break away from the rest of the electrode into the solution, the electrolyte, and begin to travel to their opposite electrode. Anions moving to the cathode, and cations moving to the anode. Yeah.
So should we touch these electrodes together?
Give it a shot.
Just for fun.
Just for fun. I can't smell anything yet.
You've taken off your safety gloves.
I've taken off my safety gloves. No, I haven't. They're flesh coloured.
Any reaction there? I can't see because your flipping hands in the way.
Well, there's no sparks.
Oh, well, that's a good thing then.
Oh no, it's not a good thing, because usually that means that the oh, that's what I was going to say. Unfortunately, we don't have any silver nitrate to use in the solution, so we couldn't exactly electroplate the copper with the silver, which is a real shame. So if anyone is willing to donate some silver nitrate, we will gladly accept. Decomposing, you know.
It is decomposing.
Yeah, it's working. It looks like the silver plating is going to come off in one piece, but I doubt that very much.
Let's see if we can't get a better shot of that. Ah, yeah, actually that's quite interesting now, because from here I can see that the silver plating is coming off, leaving the copper behind, isn't it?
Yeah.
You can definitely see the copper there, can't you?
So that means that the silver is breaking down.
Which means there is very little silver.
Very little silver there. It's breaking down into the solution. What's being given off at the cathode there?
Cathode, yeah. Electrode, cathode, whatever you like to call it.
Cathode's the negative. I have no idea.
Hydrogen, maybe?
Probably hydrogen. It's scentless. I can't smell anything. I don't think there's any chlorine coming off. That's the only thing I can think would be produced.
Does it smell gassy?
That's you.
We put some lovely like elevator music, so lift music. Lift music over the video here, didn't we? What will it sound like if I talk really slowly? Will it sound normal? Oh, it seems to be going murky. I can't imagine what's it. Oh, it's going murky. That won't work. Why? It's too far away. I haven't got my safety gloves on. Oh no, your safety gloves. Oh, please set that to my gloves now. Yep. So, it's not a good idea, I don't think that's so. Yeah, we're going to set fire to your gloves.
And obviously the cathode was nearest to the this side of the Panda, so obviously this is what the other side looked like. So we're now going to turn it round and carry on electrolysing until we have a lovely copper looking Panda.
Or we could go and have a drink. Sounds good to me. I'll stick the kettle on. Okay.
Back to electrolyte, yeah. As you will have seen, the solution turned a lovely green colour, and this is what the Panda now looks like. Well, here's what's left of our fake Panda after electrolysis. We've succeeded in removing the silver plating, I'm guessing, and there's the reverse.
Looks like there could
No,
be.
that's the reverse.
You can't even tell. Looks like there could be some kind of oxide sitting on the surface there.
Oh, that black bit there.
Or the black, yeah. Well, you can definitely see from the cathode that there was some oxide going on in there.
That's about us done then, isn't it? Until next time. As an added bonus feature, we are going to destroy another Panda for you in a different way this time.
Yeah. So here's our lucky Panda. Careful not to drop it in the solution. Lucky soon to be ex-Panda. This is a pretty nasty chemical we've got here, hence the protective gloves. This time we're being serious. We're not allowed to disclose the name to you, so here goes.
Control. That's it.
Oh,
What's it doing?
that's what it's going. It's
See if we can get a close up of that.
I can't see the pandas.
No, I can't either.
I think that might be a head there. That,
I see you're poking it again, like you poked it with the screwdriver last time.
yeah.
This time with the tweezers.
You always poke it. If you're not sure, give it a poke. Oh, he's wobbling.
Can you turn it over?
Yeah. Give it a shot. Oh. Blimey.
Oh.
That's interesting.
One disintegrated
It's not, well,
panda.
gloppy panda.
Lovely panda.
Still a bit left in there.
Well, I think we'll leave that as that then, won't we?
Yeah.
Another fake panda destroyed.
Yeah. So here we have our lovely little panda, friend.
Should we start that again?
Yeah. What will it sound like
if I talk really slowly?